In example 1, we discuss integration of sine even, while in example 2, we discuss integration of cos even. Now, let's look at how to integrate the powers of sine and cosine even. Example 3, evaluate integration of sine squared x, cos squared x dx. Let me discuss the solutions. Okay, if we want to integrate sine squared x, cos squared x dx, okay, firstly, we need to identify that the powers of sine and cosine now is even. And then, because the powers of sine and cosine is even, so what should we do is, we need to use from double angle identity. Okay, we write sine squared x to half 1 minus cos 2x, and we write cos squared x to half times 1 plus cos 2x. This is come from double angle identity. Okay? And then, we move out constant 1 over 4. How do we get 1 over 4? Because we simplify half times half. Then we move out. Okay? And then inside integration now, we have 1 minus cos 2x times 1 plus cos 2x. Then we expand and simplify, so we have 1 minus cos squared 2x. Okay, did you know how to expand it quickly? We can expand it using formula a plus b times a minus b, which is equals to a squared minus b squared. Now, we can refer from this formula, so our a is 1 and our b is cos 2x. When we use this formula, a squared minus b squared means we have 1 squared, which is 1, minus b squared, which is cos squared 2x. Actually, after this, we can integrate 1 by 1. We can integrate 1 with respect to x, so the answer is x. And then we can integrate cos squared 2x. For cos squared 2x, we still need to use even angle formula. Okay? Or, we can use identity, which is 1 minus cos squared 2x equals to sine squared 2x. How do we get this formula? Okay, this comes from identity. From cos squared x, from cos squared a plus sine squared a equals to 1. So, when we write sine squared a as a subject, so we have 1 minus cos squared a. Or we can write a equals to 2x. Okay, because now we have 2x. So, we can replace a by 2x. So, we have sine squared 2x equals to 1 minus cos squared a we replace by 2x. So, now we have 1 minus cos squared 2x equals to sine squared 2x. Okay? If we recall back in the previous introduction slide, I have made it clear that we do not directly integrate the powers of sine and cosine. If sine and cos have powers, firstly, we need to identify whether the powers are odd or even. Here, we can see that the powers of sine is even. Means that we need to repeat the technique we used at the beginning of the solution. This is actually similar to example 1, but you should note that the angle has doubled. Okay, here the angle now is double. How do we get this formula? Okay, from again from double angle identity. Okay, if we have sine squared 2x, so the answer should be half times 1 minus cos 4x. At the beginning, we have sine squared single x, and we have half times 1 minus cos 2x. The angle is double from single x to double x. Now, we have angle 2x. Okay, then we double the angle, so we have 4x here. Okay, but the technique is still same. Okay, and then we multiply 1 over 4 and half. Then we have 1 over 8. And then we can move out constant outside the integration sign. Okay, then inside integration sign, we have 1 minus cos 4x. So now, no more powers of sine or cosine. So means that now we can integrate with respect to x. Okay, so we still have constant outside here. Then we integrate 1 with respect to x. So we have x. And then still minus sine. And then we integrate cos 4x using formula integration of cos ax dx equals to 1 over sine ax plus c. This formula you can refer from chapter 1, page 11 in my handout. Okay. So when we integrate cos 4x, so the answer is 1 over 4 sine 4x, because our a now is 4. Then we expand, so we have 1 over 8x minus 1 over 32 sine 4x plus c. Okay? Coming up next, example 4, integration of cos the power of 4x dx. So, stay tuned. Bye. Assalamualaikum. See you.